Welcome back to Print Reading for Concrete, Unit 2, Basic Construction Math. My name is Dan Dorfmiller, and I will be your instructor. In this unit, we will be discussing fractions, decimal equivalences, area, and volume measurements, and at the end of the unit, we'll be doing a Test Your Knowledge activity. Let's start with fractions. They are written with the top and a bottom number, the top number being the numerator and the bottom number being the denominator. Fractions represent a portion of a whole number, as seen here in 7/16 and 9/16. Add the 7 and the 9 together, and you have 16/16, which is equal to 1. Fractions can be both proper and improper. A proper fraction is a number less than 1, like 7/16 or 3/4. An improper fraction is one that the numerator number is greater than the denominator number, making the fraction more than 1, such as 5/4 or 19/16. Both these fractions can be reduced to proper fractions by subtracting the 4 from the 5, which will give you 1 and 1/4, or subtracting the 16 from the 19, which will give you 1 and 3/16. A whole number can be changed to fractions by multiplying them by the number of fractional units that is needed. Let's say you want to take this 6 and make it quarters. You would go 6 over 1 times 4 by 4, which is the same as 1, which would equal 24/4. That is the same as 6. You can also change a mixed number with a fraction the same way by multiplying the whole number, then add the proper portion of the fraction. For example, let's convert 3 and 5/8 to all 8s. First of all, we're going to take the 3 right here, and go over 1 times 8 times 8 plus the 5/8. So the 3 times 8 is 24/8 plus the 5/8 over here, and we end up with 29/8. Improper fractions can be reduced to whole numbers or mixed numbers. For example, we have 17/4, so we would simply divide 4 into 17, and we'd end up with 4 with 1/4 left over. Reducing fractions to their lowest terms is by being able to divide both the top and the bottom number by the same number without anything being left over. As shown here in 6/8, we take 6 and the 8. We can divide both the top and the bottom by 2, which will equal 3/4. Same goes for changing a fraction to higher terms, as shown here in 5/8. Simply multiply both the 5 and the 8 times 2, and we end up with 10/16. So with that in mind, the first challenge working with dimensions is adding and subtracting dimensions with different denominators. First, find the lowest common denominator that would be needed to add or subtract the numbers. Then get all the fractions to those terms, as shown in the previous examples. In this example, we have 5/8 plus 3/4, and the lowest common denominator would be the 8. So, if the lowest common denominator is 8, we must convert the 3/4 to equal 8ths. To get the 3/4 to equal 8ths, we'll multiply both the top and the bottom times 2, and we will get 6/8. Then we'll have 5/8 plus 6/8 will equal 11/8, and then reduce down to the lowest mixed number. We'll have 1 and 3/8. Now let's talk about decimal equivalences, which are used a lot in construction. The decimal equivalence chart shown here is shown both in decimal inches and decimal feet. You cannot add decimal feet to decimal inches without first dividing the decimal inches by 12. So let's start by adding decimal inches to decimal feet, such as adding 1/4 of an inch to 1 inch, with the answer being in decimal feet. First, you must get the equivalence of 1/4 of an inch in decimal inches. That's the 0.25 here. Divide by 12 inches, and we get 0.2038 decimal feet. And then add it to the decimal equivalence of 1 inch, which is 0.0833. And when adding the two together, you'll get 0.10413 decimal feet. It's very important here to keep your units the same. As a side note, going back to the decimal equivalence chart, we can get any of the numbers that you have on this chart simply by dividing the top number by the bottom number. For instance, dividing 1 by 16, you'd get 0.0625. It's easy to see 1 divided by 2, you get 0.5. And same thing true with decimal feet. You divide 1 by 12 or a 6 by 12 or a 10 by 12 or a 12 by 12, and you'll get these equivalent decimal feet numbers. Just remember, when you're in decimal inches and you want to be in decimal feet, you take the decimal inches and divide by 12 to get decimal feet. Figure in area measurements. Most people understand this from grade school. The most important thing here to keep in mind is being consistent with your units, such as square feet, square yards, etc. The area of a rectangle or a square is simply length times width. For example, 10 foot by 12 foot equals 120 square feet. Note that I did not just say 120. It's 120 square feet. If lengths are given in feet and inches, you must convert to decimal equivalences, then do the math, or use a smart construction calculator. For example, we have 12 foot 3 inches times 10 foot 6 inches. First convert to decimal feet. So we would have 12.25 feet times 10.5 feet. When multiplied out, we would get 128.625 square feet. The same is true if you start in inches. For instance, we have 76 inches times 12 foot 5 inches. Here I'm going to convert the 76 to 76. I'm going to convert the 12.5 to 149 inches. Multiply both out, I get 11,324 square inches, and then I divide that by 144 inches to a square foot, and I get 78.64 square feet. To obtain the area of a triangle, you would multiply the height times the base divided by 2, as shown here in this formula. A equals B times H divided by 2. So for instance, if you have something that's 5 feet high, 24 feet long, you would get 120 square feet. Divided by 2, you end up with 60 square feet. The next shape I would like to investigate is a trapezoid. It simply means that the top, this line is parallel to that line, but there may not be any other parallels. It's a lot easier than it really looks. The formula is the area equals A plus B, which I'm going to add the 10 and the 14 together, divided by 2 times the height right here. So in the example above, you would have 10 foot plus 14 foot divided by 2 gives you 12 foot and 12 times 5 equals 60 square feet. So how does this apply to construction? Well, let's just say we needed to find the area of this building right here. Well, what I do is I start breaking things down into shapes. We have a shape here, which we can easily find dimensions. We have a shape here. We have a shape number 3 here, number 4 right there. These little pieces, 5. I guess that's all the shapes. And then we just simply find these dimensions along the sides and the tops, wherever they may be, adding pieces of this dimension here and pieces of this dimension over there, multiply them all out, and we would come up with a total square footage. Here we're showing the total square footage. We have 190 times 40, it gives you 7,626, and when all added together, we have 61,649 square feet of total slab area. Now let's talk about circles. First, you need to become familiar with the nomenclature of circles. We have the circumference, which is a line that goes all the way around the outside. We have the diameter, which is a line from one side to the other, crossing the midpoint. And then we have the radius, which is 1/2 the diameter. Once we are familiar with these references, pi is the magic number that makes the formulas work. Pi equals 3.14159. And I simply round that off to 3.1416. The circumference of a circle, the formula is pi times d, the diameter. So let's find the circumference of a circle that has a diameter of 6 foot 6 inches. So first, let's take the 6 foot 6 inches and convert it to 6.5 feet. Then multiply it times pi, which equals 3.1416. When multiplied out, we get 20.42 lineal feet. How this could apply to construction, let's just say we needed to find this length along here of a parking lot curb that had a radius of 4 foot 3 inches and an arc of about 90 degrees. So the first thing we needed to do is determine the circumference. Now we're looking at a radius, so it's 4.25 times 2 to get the diameter, times pi, which is 3.14. I've got it here as 1.5. It could be 1.5 or 1.6, equals 26.7. Next, determine the portion of an arc. So to determine the portion of this arc, this is 360 degrees. We're using 90 of these degrees. So 90 divided by 360 gives you 0.25 or 25% of the total circle. Finally, multiply the circumference by the determined portion of the arc. You end up with the 26.7 times 0.25 equals 6.68 feet, and that can be converted back to 6 foot 8 inches. Next, let's find the area of a circle. The area of a circle again relates back to pi. It's pi times r squared, which stands for the radius squared. So to find this area down here, we would go pi times r squared, writing the formula down. Then we have, so pi times 15 foot, which is the radius squared, and we have 3.1416 times 15 times 15, which is 225 square feet. The final answer giving you 706.86 square feet. A shortcut to finding the area of a circle would be to use the percentage of a circle to a square, and that is simply d squared times 78.5. So if you had a diameter of 8 foot 6 inches, 8.5 times 8.5 would give you 72.25 times 78.5 would give you 56.71 square feet. And if you did it the other way around, you would get 56.74 square feet. So you can see that the answers are very, very similar, certainly good enough for estimating. To find the volume of a particular item, you just simply multiply the area, figure the area out here, and multiply it times the height. Just remember, it's very important to keep your units correct. Going back to our patio problem, let's now figure out the volume of concrete that might be needed. The concrete is 4 inches thick, so the first thing needed is to convert the 4 inches to decimal feet. 4 divided by 12 gives you 0.333 or 0.334. Then multiply it times the square feet. So 706.86 times 0.333 equals 235.38 cubic feet. It's important to remember the cubic feet. And to convert this to cubic yards, you just simply take the 235 divided by 27 equals 8.71 cubic yards. At this point, go to your student handbook and find the 5 pages of exercises at the end of Unit 2. Problem number 1, convert the following fractions to their lowest terms. In problem number 2, add the following fractions and reduce to their lowest terms. In problem 3, convert the following fractions into decimal inch equivalences. And in problem 4, convert the following into their decimal feet equivalences. In problem number 5, let's find the area of the following objects. This is usually a lot of fun. In problem number 6, find the volume of the following patio that is 5 inches thick. Give the answer in cubic feet. And in problem number 7, find the length along this following line. Using the Gateway Tower drawings, answer the following 5 questions. Please pause the video now. Number 1, convert the following fractions into their lowest terms. 14/16 can be reduced to 7/8. 4/8 can be reduced to 1/2. It's interesting here, we have 4/2 can be reduced to 2. And here we have 3/8, and it's already in its lowest terms, 3/8. Number 2, add the following fractions and reduce to their lowest terms. 3 plus 7 gives you 10/8, can be reduced to 1 1/4. 5/8 plus 3/4 has to be reduced to 11/8, which equals 1 3/8. 3 plus 13, we're already at 16, gives you 16/16, and that is equal to 1. 7/16 plus 1/2 is 15/16, and that would be its lowest terms. 3 9/16 plus 2 3/4 equals 5 21/16, and you divide the 16 into 21, and you can reduce that down to 6 5/16. Question number 3, convert the following into their decimal inch equivalences. 1/16, or 1 divided by 16 would get you 0.0625, 5/8, 0.625, 3/4, 0.75, 1 7/16, 1.4375, and 3 3/8, 3.375. Question number 4, convert the following into their decimal feet equivalences. 2 foot 4 inches, 2.34 feet, 7 foot 8 inches, 7.67, 3 foot 2 inches is 3.18, and 5 foot 6 1/2 inches equals 5.5416 feet. 9 foot 7 3/4 inches equals 9.645883. Now, it's not necessary always to carry out to this many decimals, especially in construction. You simply could have written down 9.65, rounding the 4 up to the nearest number. Question number 5. Find the area of the following objects. A. It's real simple. Just multiply 10 foot 7 by 6 foot 2 and you'll get 65.38 square feet. B is a little bit more interesting. Remember when we talked about dividing things into area 1 and area 2. And when you do that, you get 110 by 40 gives you 4,400 square feet. Area 2 is 110 minus this 50 times 12 gets you 640 square foot. You add the two together and you get 5,120 square feet. C is also pretty simple. It's just simply 8 foot 7 inches times 19 foot 9 inches, and then you divide the whole thing by 2. D, what is the area of a circle? Do you remember what this formula is? The formula is very simple. It's just simply pi r squared, r being the radius. To work out the math, we have 37.5, which is 37 foot 6 inches, divided by 2 equals 18 foot 0.75 squared equals 351.56 square feet. And then you multiply 351.56 times pi, which is 3.1416, and you get 1,104.43 square feet. Moving on to E. Again, what would the formula be to figure out this portion of a circle? Really quite simple. Pi r squared. That gets you a whole circle, times the percentage of the area of this circle, which is we'll show you the math here in a second. The math would be 16.5 divided by 2 gives you 8.21. Square that and you get 67.4. Take the 67.4 times 3.1416, which is pi, and you get 211.757. And then we need to find this portion of a circle, and that is simply 260 divided by 360, and we get 0.722, which is the percentage of this area of a whole circle. Multiply the 0.722 times the area that you got up here, and you end up with 152.88 square feet. For F, what is the formula for a trapezoid? The formula for a trapezoid is A plus B, and we're trying to average these two out, so it's divided by 2 times the height, which is right here, and the final answer would be 172.218 square feet. Number 6. Find the volume of the following patio that is 5 inches thick. Give the answer in cubic feet. The first thing you want to do is break this shape down here into area 1 and 2. Area 1 being the 18 by 12, 216 square feet. Area 2 being this half circle, which is pi r squared times pi. Here, r squared gives you the 113.1 square feet times half the circle gives you 56.55 square feet. Add area 1 and 2, 216 plus 56.55,
get 272.55 square feet. Next, convert the 5 inches to decimal feet, 0.42. Multiply it times the area that you had above, and you get 114.47 cubic feet. Number 7, find the length of the following line. The first part of it is very easy. 4 foot plus 6 foot plus 10 foot right here. The hard part is finding this arc right here. So let's take a look at that. The arc really is quite simple. What it really is a portion of a larger circle. So find the length around the larger circle, which is pi times d. To find that, we've got pi here, and to get d, this is the radius, it's just simply 2 times the radius. Then you multiply it out and you get 62.831 lineal feet. The arc is really also quite simple. A whole circle is 360 degrees, so take 110 divided by 360, and you get 0.3055. Multiply the 3.0055 times the 62, and you get 19.198. Add it to this, round it off, and you get 39.0 lineal feet.
Using the gateway tower drawings, what is the distance from the southeast corner of the building at column 8.6 going north on the 3rd floor? And the answer is 29 foot 7 inches. Number 2, what is the cubic yards of concrete and square foot formed of surface required for column 10B and 8.6E from the 1st floor to the 2nd floor? Do not deduct for the thickness of the floor, which is 7.5 inches. The cubic yards would be 3.9 order 4 yards, and the square footage of form would be 229 square feet. Number 3, answer the following about the penthouse roof drawings. What is the overall area? 6,561 square feet. Lineal foot of edge formed to the nearest foot, 330 lineal feet. What is the cantilever off the columns? 4 foot 6 inches. Number 4, what is the offset of the typical exterior column and edge of slab on the 2nd floor forming plan? And that is 2 inches. What is the cubic yards of concrete required for the wall footing from column lines 1 to 5 along column line A? And the final answer is 3.4 cubic yards. Congratulations, you have completed the math unit in unit number 2. Next, go to unit number 3, learning how to use an architect's and engineer's scale. Look forward to seeing you there. If you have any questions, please feel comfortable to email me at dorf@dorfmiller.us.